let's have a look at this one. We'll see that, like we said before, we are trying to look for the functions that we have. Now, if we look at this, the problem is that we can see that we have two functions. There's this one and that one. And so our first thought, our first strategy is always going to be, okay, we know now that we've counted, we've got two functions, but what's the relationship? A lot of us can make the mistake of saying that this is a product. Okay, this is not a product, this is a composite function. Okay, if you remember, this is a function inside another function, so this is composite. I don't know if you remember, we used to do something like this gx there. So this we said that they were composite, and this will be different from fx, fx and gx. Okay, these two are different, and we emphasize that we need to be able to see these. So you can see that this is composite, and they are separate. Okay, so these are composite, these are separate. So it's the same here, we have composite kind of function. Now, we also mentioned in our previous video that these actually, the best method whenever you see that this is a composite function, okay, and you need to access the inside of that function, the best is actually to use what? The best is to use the chain rule. Okay, because it's the only rule that is very invasive. It can actually go inside another function. So now that we've known that, we are going to say that u is equal to that same function. We start with the function which is inside. So that's sine x. Sine x, that's going to be u. And the main function now, which is going to be, we're going to maintain it as y, is going to be tan u. Okay, now you can remember the chain function. We said that it's going to be dy over dx is equal to, what did we say? We said that we are going to say that it starts off with dy because we want dy here, and then we're going to say du, meaning that we're going to work with this function, right? Then we said we multiply it with du over dx. Now we're not going to cancel these at this point because these are just notations. You can't cancel this and that because you get dy dx again. It will prevent you from achieving anything. Okay, so now we just want to make sure that we find derivatives of these. Now we said the derivative of tan u, okay, we said it's sec squared, but this time it will be u, okay, because that's the one that we've put here. Then du dx, which is going to be this one here, okay, we're going to differentiate that. Du dx is going to be what? It's going to be cos x. So this now we can go on and simplify. So this is going to be cos x as the first one. Then here we're going to replace with u. U is what? U is sine x. So we're going to say sec squared sine x. So this is dy du. So the change in x over the change in y, the change in y over the change in x is going to give us cos x times sec squared sine x, and that will be our derivative. All right.